Okay, kids, so any of the ones on 1 through 48, what do you want to ask about? Anything you want on 1 through 48?
33.
33. 33. So 33 is the square root of 2 times the cube root of 2?
Yeah.
What's the square root of 2?
2 to the
What's the cube root of 2?
2 to the
What do you do with the powers?
plus.
Add them. So 2 to the? All done. All done. There's nothing to do to that.
Wait.
1/2 plus 1/3 is 5/6. Right? I hope so.
Yeah.
Any others? Nell? Best number ever. Okay. 47. Sure. 47 is x to the 2/5, y to the negative 1/5, all over x to the negative 1/3 to the 3 over 2. What do you do with the 3 halves? You distribute through everything. So it's going to be x to the 6/10, y to the negative 3 over 10, over x to the what? Simplify those before you do anything. X to the 3/5, y to the negative 3/10 over x to the negative what? Negative 1 over 2, yep. So then you can do x to the 3/5 over x to the negative 1/2 times x times y to the 3/10 times y to the negative 3/10, sorry. Okay, so then what do you do with powers of powers? What do you do with this one? What does that become? To the 3/5 minus negative 1/2, right? Times y to negative 3 over 10. So that's going to be x to the what power? 11/10 over y to the 3/10 because it's the negative power. All done. You could if you wanted to. This is what I would do to simplify that. To the what power? That's what I would do. If I wanted to make it as pretty as I could possibly make it, that's what I would do.
Wait, how did you drop from y to the negative 3 times?
Because it's below now. Now it's in the denominator. Bounces down because of the negative. That's what I would do to make it super pretty. Not 100% necessary, but I like it. Gets me less compound fraction, less fractions. Only one fraction. A little 2 in there. Other one. Any 1 through 48. Yes?
48.
48? You guys just don't like the fractions, huh? Yeah, that's true. Okay, so what do you do with all those powers? Multiply them out. So you get x squared over y to the 8th times y over negative 2, right? So it's x to the 2 minus negative 2 times y to the 1st minus 8. X to the 4th, y to the negative 7. So if you're going to write this in just positive exponents, x to the 4th over. Yep.
Wait.
I won't scroll for a sec, sure. So you have, kids, you have to use the common bases. There those are. So it's x squared divided by that. That's an x right there. Sorry. It's an x. And then you have the y's right there. Boom. Then cross.
Oh,
They're just, it's a multiplication. You can move them anywhere you want. Yes.
Can we do like 25? Because I don't get how to do it in the base
25. Well, on 25, the bases are the same. What do you see?
2
You see 2. What is 4?
squared.
So just turn 4 into 2 squared and you're home free. Well, actually 2 ways. I'll do this in 2 different ways, okay? So the first way is 2 to the 1/3 times 2 squared to the 1/3. So that's 2 to the 1/3 times 2 to the, which is 2 to the 1/3 plus 2/3, which is 2 to the 3/3, which is 2 to the 1, which is 2, right? Or one thing you can do, this is the same as 2 times 4 to the 1/3, which is 8 to the 1/3, which is the cube root of 8, which is... Oh, you can do that because you have a rule here. You know that a times b to the n is equal to a to the n, b to the n. That only works because these are being multiplied together. They have to be what?
Multiply together.
Have to be multiplied together, have to be multiplied together, have to be multiplied together. They have to be multiplied together. You think you guys will survive till the end of the semester here with me? No?
What's wrong? Talk to his chickens.
Here we go. Any other questions on 1 through 48? Anything else? Okay.
2?
No.
Don't. Okay.
So what I would like you to do right now is page 4, which is the CBL lab, with somebody you have never worked with before in this class. See if you can do that.